Okay. Good morning, my dear boys. Today is 29th of June 2021, fourth period. Today is the 10th day of myself doing this chapter, some basic concept of chemistry for class 11 science. Okay. Now, I request you to please keep your exercise copies ready and write down the heading simple volumetric calculations. Calculations based on mass percentage, volume percentage, normality, molarity, molality, and mole fraction. So I will do maybe one or two numericals based on all these concentration terms which I have explained in my previous class. Okay. So the first question, I am writing the first question for today. The first question you can write down. Question number one. Question number one. 10 gram of sucrose sucrose are dissolved in 100 gram of water. Find the mass percentage. Find the mass percentage of sucrose sucrose in the solution. This is the question. Please copy the question. I want all of you to copy the question. Those who are there in the class. 10 gram of sucrose are dissolved in 100 grams of water. Find the mass percentage of sucrose in the solution. When I say mass percentage, I mean W by W. And the concept of mass percentage I have explained you in the previous class. Okay. Now, the solution for this question, let us do it. The solution for this question. Now, write down what is given in the question. What is the mass of sucrose? Mass of sucrose dissolved. Mass of sucrose dissolved. Mass of sucrose dissolved, it is given 10 grams. Mass of the solvent, mass of water, that is mass of water, and it is the solvent, it is given 100 gram. Okay. So from here, from these two, we can get the total mass of the solution. Total mass of the solution. The solute plus the solvent. Total mass of the solution, it is equal to 10 plus 100, that will give us 110 gram. Now we know the formula for mass percentage. So in this case, mass percentage of sucrose is equal to mass of solute divided by mass of solution. mass of solution into 100. Okay. So the mass of solute is 10, mass of solution is 110 into 100%. So if you simplify this, you will get 100 by 11. You will get approximately 9.09%. So 9.09 we can write 9.09 W by W. Okay, that is how you do this sum. Look at the working, it's very easy. These are some basic problems required. Okay, basic problems, very very basic problems over here. Okay, I hope everyone has got this clear. Okay, now shall we go to the next sum, boys?
Sure. Yes,
Yes,
sir.
sir.
Yes, sir.
This is the problem, volumetric calculation based on mass percentage, which is the first concentration term. Okay, that is mass percentage. Now let us go to the next one. Next one. I go to the next page, next slide now. Question number two. Please copy this as well. Question number two. Question number two. Write down sample, a sample of nitric acid is 55% by mass. It is given 55% by mass, 55 W by W. Okay, there is a sample of nitric acid containing 55 W by W, means 55% by mass of nitric acid in it. Okay, now they are telling us calculate the mass of calculate the mass of nitric acid nitric acid present in 100 centimeter cube of the of sample if its density if its density if its density is 1.36 gram per centimeter cube. Okay, this is the question. A sample of nitric acid is 55% by mass. Over here in this second question, it is also a problem based on mass percentage. But here in the question, the mass percentage is given. Now they're using this mass percentage, they are telling us to find the mass of nitric acid which will be present in 100 centimeter cube of the sample. That means the volume of the solution is 100 centimeter cube. 100 centimeter cube of this nitric acid contains what mass of nitric acid they want to find out. Okay, this is a backward question. Okay, we have to go backward. Now, to solve this sum, solution part. Now, Since the given sample is 55% of mass, what does this mean? This means that we can write down the sentence. Since the given sample is 55% by mass, which means 100 gram of the sample 100 gram of the sample would contain 55 gram of the acid 55 gram of the acid, that is nitric acid. Now here it's given volume, so let's use the formula. Since density formula is mass by volume density formula is mass by volume, so therefore the volume volume of 100 gram of the sample 100 gram of sample will be equal to, volume is equal to mass by density. So mass by density, I write mass is, I've taken 100 gram, density is given in the question 1.36. So upon simplification we get 73.5 centimeter cube. So 100 gram of the sample is having a volume of 73.5 centimeter cube. Okay, so this is what we have got, the volume. Thus you can frame a sentence over here. 73.5 centimeter cube of the given sample contains 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 here it is 55 gram, you can write contains 55 grams of nitric acid. Okay, so 73.5 centimeter cube of the given sample contains 55 gram of nitric acid, but the question is asking 100 centimeter cube. Therefore 100 centimeter cube of the given sample will contain 100 multiplied by 55 divided by 73.5. So we simplify this. Upon simplification we will get this approximately 74.8 grams, which is the answer. Okay. So this is the second one. I repeat this working once more. A sample of nitric acid is 55% by mass, 55 W by W nitric acid. The question is saying calculate the mass of nitric acid present in 100 centimeter cube of the sample if its density is 1.36 gram per centimeter cube. Now 55% by mass means 100 gram of the sample contains 55 gram of nitric acid. So applying the formula for density mass by volume, we get the volume of 100 gram of the sample first. 100 gram of the sample. So the volume of 100 gram of the sample will be equal to mass by density 100 by 1.36, that is coming to 73.5 centimeter cube. Which means that 73.5 centimeter cube of the given sample volume, this volume of the given sample contains 55 grams of nitric acid. Therefore, 100 centimeter cube of the sample will contain 100 into 55 divided by 73.5, which gives us 74.8 grams of nitric acid. Okay, so the solution is done. Okay, now let us go to the next question. Question number 3. Question number 3. Question number 3. Okay, write down 1 liter. 1 liter of 1 liter means 1000 milliliter or 1000 centimeter cube. 1 liter sample of sea water is is found to contain is found to contain 5.8. 1 liter sample of seawater is found to contain 5.8. 5.8 is found to contain 5.8 into 10 to the power of minus 3 grams of dissolved oxygen gas. Dissolved oxygen. So if I take 1 liter of seawater, it contains 5.8 into 10 power minus 3 grams of dissolved oxygen. Now the question is calculate the concentration. Calculate the concentration of dissolved oxygen. Concentration of dissolved oxygen in seawater in seawater in ppm, parts per million, in ppm, if the density of seawater seawater is 1.03 gram per centimeter cube. Okay, this is the question. I repeat the question once more. 1 liter of sample of seawater is found to contain 5.8 into 10 power minus 3 gram of dissolved oxygen. Now we are supposed to calculate the concentration of dissolved oxygen in seawater in parts per million. 1 million means 10 to the power of 6. I hope you still remember that. Okay. Now for the solution part, we have to find the mass of 1 liter of seawater. Okay. We have to find the mass of 1 liter of seawater. Mass of 1 liter of seawater. 1 liter means 1000 centimeter cube. The formula, apply the formula of density. Density mass by volume. No? So mass will be volume into density. So here we write volume into density. Volume into density. Okay. So volume, here I put how much? 1000. Volume of 1 liter of seawater means 1000 centimeter cube. 1000 multiplied by 1.03. This will give me mass of 1 liter of seawater to be equal to 1030 gram. Okay, 1030 gram. Okay. Now I can say thus 1030 gram of seawater contains contains 5.8 into 10 to the power of minus 3 grams of dissolved oxygen. oxygen. This I can write down from here. Okay, now we have got the mass of 1 liter of seawater. Okay, that is 1030 gram. This 1030 gram of seawater contains 5.8 into 10 power minus 3 gram of dissolved oxygen. Okay, now we are supposed to get this in parts per million. So therefore, therefore, mass of oxygen present in 10 to the power of 6 gram of seawater. Seawater. This 10 to the power of 6 gram means 10 to the power of 6 means 1 million. 1 million grams of seawater. Therefore, the mass of oxygen present in 10 to the power of 6 gram of seawater will be equal to how much? 10 to the power of 6 unitary method multiplied by 5.8 into 10 to the power of minus 3 divided by 1030. So, this I will get the answer in grams. That is also called parts per million. Upon simplification, I can get over here, it will come approximately 5.63 grams, which is also written as 5.63 ppm. This is the answer, which means 5.63 ppm means 5.63 grams of oxygen is present in 10 to the power of 6 grams of seawater, or present in 1 million grams of seawater. This is the answer. Okay, this is question number 3. Mass percentage in terms of parts per million. Number 3 is over. Okay, now let us go to the next sum. The next sum for today. That is question number 3. I hope you have finished copying this down. Okay, shall we go to the next question, boys?
Yes, sir.
Okay, question number 4 now.
Yes, sir.
Question number 4. Question number 4. Okay. Now, this question number 4 is a problem based on molarity. So, I'm writing down the question. It's an easy question. Write down 4 grams of sodium hydroxide, NaOH. 4 grams of sodium hydroxide are are dissolved dissolved in 200 centimeter cube of water. Okay, 4 grams of sodium hydroxide dissolved in 200 centimeter cube of water. Okay, find 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 the molarity find the molarity of the solution. Find the molarity of the solution. Okay, now what is the formula for molarity, which I have explained yesterday in my previous class? Molarity formula. Molarity, what is the formula? N by V, no? Number of moles divided by volume in liters, no? Correct. So to get the number of moles, we have to put W by M. I can write M dash because molarity is capital M. And now where volume of the solution liters is V divided by 1000. This is what I had given formula in my previous class. Okay. So here, if I put the value for W, the mass of the solute sodium hydroxide is 4 grams. It is 4 divided by molecular mass of sodium hydroxide is, for sodium hydroxide molecular mass, sodium hydroxide molecular mass becomes 23 plus 16 plus 1. That comes to 40. So it is 4 by 40 divided by volume given in centimeter cube. It has to be converted to liters. So 200 divided by 1000. Okay. So upon simplification, the molarity of the sodium hydroxide solution, capital M, comes to how much? This is 1 by 10. This will cancel, we'll cancel this. 2 by 10, 1 by 5. So 1 by 10 divided by 1 by 5, it is coming to 0.5, 0.5 moles per liter. Answer. Okay. This one is 1 by 10 divided by 2 by 10. So 1 by 10 into 5 by 1, like this. 1 into 5 is a 10. So it's coming to 1 by 2. 1 by 2 means 0.5. Okay. These are all working. So this is the answer. Okay. So this is how you have to direct application of formula. Molarity is number of moles of sodium hydroxide divided by volume of the solution in liters. Okay. Now this is clear to all of you. Number 4, my dear boys.
Yes, sir. Yes, sir.
Now let us go to the next sum. Question number 5. Question number 5. Okay. Question number 5. Okay. Copy the question. I am writing down the question for you all. Find find the mass. Find the mass of uh, sulfuric acid. Find the mass of sulfuric acid present in present in 100 centimeter cube 100 centimeter cube of a decimolar solution of a decimolar decimolar solution. Now I had given a table in my previous class. Decimolar. What is the meaning of decimolar? Decimolar means what? 1 by Decimolar means what? I've given you a table in the previous class.
1 by 10.
1 by 10. Decimolar means 1 by 10. Very good. 1 by 10 moles per liter or 0.1 moles per liter. Okay. Now, if you remember the formula, they are telling us to find the mass. They're telling us to find the mass of sulfuric acid present in 100 centimeter cube of a decimolar solution of this. Now, if you remember the formula for molarity, the formula for molarity which I have given in my previous class, capital M stands for molarity, is equal to W multiplied by 1000 divided by W multiplied by 1000 divided by small v into M dash, molarity. No, this is the formula. Just check. The formula for molarity is M is equal to yes, molarity is M is equal to W into 1000 divided by V into M dash. Correct, no? Correct, no, all of you?
Yes, sir.
W into small w into 1000 divided by small v into M dash. Now this small w means what? Mass of the solute, 1000 is there. This small v means mass of the solution, volume of the solution liters, and this M dash means the molecular mass of the solute. Okay. Now we can just put the values directly in this formula. This is the formula for finding the molarity, but we already know the molarity of the solution, sulfuric acid. They are telling us to find the value of small w, that is the mass of sulfuric acid. So I will rearrange this formula. So this formula becomes W is equal to, the small w is equal to M, capital M, into M dash into small v. This is going up, divided by 1000. Divided by 1000. This is the formula. for getting the mass of sulfuric acid present in 100 centimeter cube of the decimolar solution of this sulfuric acid. So now I will put the values over here. W is equal to, what is M? Molarity is decimolar, no? Decimolar means 1 by 10. 1 by 10 means 0.1. So I'll write over here 0.1 into M dash. Molecular mass of sulfuric acid can be calculated mentally. Sulfuric acid formula is H2SO4. So 2 plus 32 plus 2 plus 32 plus 16 for the 64. So add this 64, 94, 96, 98. The molecular mass of sulfuric acid is coming to be 98. It is coming how much? 98. So I'll put over here M dash value 98 multiplied by small v, volume of sulfuric acid 100 centimeter cube. I'll put over there 100. I'll put over here 100. Okay. Now this gets divided by 1000. Divided by 1000. Okay. Now upon simplification, the mass of sulfuric acid I'll get over here. You can cancel this too. You know, 9. This also you can cancel 9.8. 9.8 to 0.1 becomes 0.98 grams. So this is the mass of sulfuric acid present in 100 centimeter cube of the given solution. Okay, so you can write a sentence over here. Hence 100 centimeter cube of the given solution of the given solution contains 0.98 grams of sulfuric acid. Answer is there. Okay. So this was question number 5. Okay. A problem based on molarity. Okay. Problem based on molarity. So far so good. Okay. Now now I will give you one question which you may try it on your own for your homework. Okay. And if you can do it, well and good. If you can't do it, then I will show you the steps and the working in the next class. Okay. Now so write down question number 6. Question number 6, which will be a part of your homework. Okay. Homework. I'm writing down the question. Write down. It is a problem based on normality. And normality, I've given you the formula, I've given you the definition. Okay. So write down a solution. A solution is prepared by dissolving 0.63 grams of oxalic acid. Oxalic acid. Oxalic acid. I am giving the formula also. Oxalic acid. It is like this: COOH twice dot 2H2O. This is the formula of oxalic acid. Okay. COH twice dot twice H2O. Crystals of oxalic acid. Okay. A solution is prepared by dissolving 0.63 grams of oxalic acid in 100 centimeter cube of water. Of water. So the question says find the normality. Find the normality of the solution. Normality of the solution. This is the question. Okay. So I've given you the formula for normality in the previous class. Try to work out this as your homework. Okay. Okay. Try to work out as your homework. For this question, I'll just tell you the answer also. You should get answer zero point 0.1. 0.1 gram equivalent per liter. Okay. But I would like to check your working. Okay. I would like to check your working for this homework. In the next class with you all. I have a class with you all tomorrow in the fifth period. Okay. Understood no? Okay. Now, please hang on over there only. I would like to take attendance before leaving you all. Only 39 boys today. 9 boys are missing. What happened to the 9 boys today?
Sir, I don't know.
Hmm, okay. So now you may leave the class, okay?
Thank you,
Or
sir.
be ready for the next class.
Thank you, sir.
Okay.